Hello, and welcome back to Astronomy for Sleep, where science slows down and the universe becomes a gentle story you can dream through. Take a deep breath. Let your body sink softly into stillness. The outside world can wait. For now, there is only this moment. Only you and the quiet rhythm of the cosmos. Above you, imagine time flowing like a vast, invisible river. It moves through galaxies, through atoms, through you. Every second you breathe is a ripple on that endless current, connecting past, present, and future in one continuous motion. But what is time? Really? Is it something that passes, or something we move through? Why does it flow forward and never back? Could it stop, bend, or even loop upon itself? Tonight, we explore these questions. Gently, one fact at a time. So close your eyes, let your thoughts drift, and follow me through 101 sleepy facts about time, the fourth dimension of the universe. Time is not a thing, but a measure of change. We often speak of time as if it were a river, something that flows past us, carrying moments away. But in truth, time is not a substance or a force. It is a measure, a way for the universe, and for us, to describe change. Without motion, without transformation, there would be no way to tell that one moment is different from another. Time is the comparison between states, between what was and what is. A clock, a heartbeat, even the flicker of thought, all of them are instruments that translate change into sequence. What we call the passage of time is simply the unfolding of the universe itself. Time is not outside of things. It is woven into the process of existence. It is not something we move through. It is what happens when things move at all. Every clock, from atoms to hearts, measures motion. The universe is filled with clocks, though most of them don't tick. An atom vibrates billions of times per second, and that vibration defines one of the most accurate measures of time we know. A planet turns on its axis. A star pulses. Even the beating of a human heart counts moments. In their essence, all clocks do the same thing. They compare repeating motions to mark intervals. What your watch calls a second is a pattern of vibrations in the cesium atom, chosen for its perfect regularity. Your body has its own internal clock too, guided by rhythms of light, temperature, and hormones. Every living thing carries a pulse, a sequence that divides the infinite continuum of change into countable steps. Clocks do not create time. They translate it into something we can feel, see, and measure. In physics, time links cause and effect. Every event in the universe happens within a sequence, one thing leading to another. This sequence gives meaning to cause and effect. You strike a match, and then it ignites. You drop a stone, and then it falls. This order is defined by time. Without time, causality would lose its meaning. Everything would be simultaneous, and before or after would vanish. Physics depends on this structure. Equations describing motion, energy, and even the quantum world all include time as a fundamental variable. It's what allows change to have direction. In this sense, time isn't just a background dimension, it's the thread that holds reality together, ensuring that consequences follow causes and that the universe doesn't collapse into chaos. Time keeps the story of existence coherent. Without change, there would be no sense of time. Imagine a world where nothing moves, nothing grows, nothing decays. A world frozen in perfect stillness. In that world, time would exist mathematically, but not experientially. You wouldn't feel it passing, because nothing would ever change. This reveals something profound. Time, as we experience it, is not an independent flow. It is tied to change itself. When the seasons shift, when your breath rises and falls, when light fades into night, you feel time moving. The perception of time is the perception of change. Even the ticking of a clock is a reminder that motion continues. And so, when change ceases, in deep sleep, and silence in the stillness of space. Time seems to slow or even disappear. Perhaps time, at its heart, is the rhythm of change itself. Ancient civilizations measured time by the sun. Long before physics, time was a relationship between humans and the sky. The rising and setting of the sun marked the rhythm of survival. Shadows lengthened, then disappeared, then grew again. The first sundials drawn on sand and stone. The Egyptians built obelisks that cast moving shadows. The Babylonians divided the day into 12 segments. Timekeeping was born from observation. The heavens became humanity's first calendar, the sun and moon their great celestial clocks. To measure time was to understand the world cycles, the floods of the Nile, the seasons of harvest, the return of light after winter. For early humans, time was sacred because it connected Earth to the cosmos. It was not yet mechanical, but cosmic, a living relationship between motion in the sky and life below. A day is the Earth's rotation, a natural clock. Every morning, the Earth completes another turn. One rotation, 24 hours, defines the cycle of day and night. This spin is steady, like a cosmic heartbeat. It sets the rhythm for everything that lives on the surface, the opening of flowers, the migration of animals, the sleep and wake of humankind. A day isn't an arbitrary number. It's a reflection of motion. The sunrise you see is proof that the planet beneath your feet is spinning. If the Earth stopped turning, there would be no days, only endless light or endless dark. Each dawn and dusk are the hands of the planet's great clock, sweeping across the face of the sun. We live by this rotation, even when we forget it, synchronized to a dance that began billions of years ago. A year is the Earth's journey around the sun, while a day marks our planet's spin. A year records its vast orbit. Earth travels about 940 million kilometers each cycle. A cosmic pilgrimage around the sun's seasons are the markers of that journey, the tilt of the planet causing warmth and cold, growth and rest. For ancient observers, this annual rhythm defined time on the grandest scale. The stars shifted in the sky, constellations appeared in new positions. To them, time was not just motion, it was migration through space. Even now, we count our lives in revolutions, birthdays marking another circuit completed. Each year, the Earth returns nearly to where it was, but never exactly, because both it and the sun are moving through the galaxy. So each year is not a circle, but a spiral, time looping forward through space. But time itself doesn't depend on the sun, only on motion. The sun gives us our calendars, but time would exist even in darkness. On worlds without sunlight, drifting in deep space, motion still occurs. Electrons orbit nuclei. Stars orbit galaxies, and galaxies themselves drift through the cosmic web. Time is not bound to light, but to change. Even if every star were to fade, particles would continue to move. Vibrations would persist, and the universe would still unfold. The sun is our teacher of time, not its source. What it shows us each day, the passage of light and shadow, is a local reflection of a universal truth. Time is written into motion itself. The cosmos doesn't need a sunrise to keep its rhythm. It beats endlessly, with or without the warmth of our local star. The universe has its own cosmic clock. Beyond the cycles of Earth, there exists a larger clock, the cosmic one. Astronomers measure the age of the universe not by rotations or orbits, but by expansion. Galaxies drift apart, carried by the stretching fabric of space-time. This expansion acts as the universe's ticking hand. Each moment, space itself grows larger, colder, more diffuse. By tracing that expansion backward, scientists estimate that time began 13.8 billion years ago. The cosmic clock started with the Big Bang, and it has been running ever since. Unlike our human clocks, it doesn't reset, it only expands forward. And yet, in that steady unfolding lies the record of all cosmic history. The galaxies are numbers on its dial. The background radiation, its silent ticking. Every second is the universe, marking its own age. Time may have begun with the Big Bang. Before the Big Bang, there may not have been a before. According to modern cosmology, time itself began with the universe's birth. When all matter and energy emerged from an incredibly dense state, space-time came into existence. Asking what happened before the Big Bang is like asking what's north of the North Pole. The question loses meaning. In those first fractions of a second, time as we know it didn't yet behave smoothly. It flickered and foamed, tangled with quantum uncertainty. Then, as the universe expanded and cooled, time stabilized, allowing events to unfold in sequence. Every atom, every star, every thought that exists today is part of that same timeline. You are living within the Great Expansion, part of a clock that began when existence itself began to tick. Before that moment, before had no meaning. The idea of before time began is paradoxical because time defines before and after. If the Big Bang was truly the beginning of time, then there was no before, not because something prevented it, but because the concept doesn't apply. The absence of time is the absence of sequence. No cause, no effect, no waiting. Just timelessness, a condition beyond comprehension. Physicists describe it as a singularity, where all known laws break down. In that singular instant, potential and existence were one. From it came space, energy, and time itself. So when we ask, what existed before, the truest answer may be, nothing, not even time. The universe did not emerge in time. Time emerged with the universe. Every tick since then is the unfolding of that original creation. Einstein called time the fourth dimension. Before Einstein, space and time were seen as separate, one describing position, the other progression. Einstein united them in a single structure, space-time. Just as an object has length, width, and height, it also exists within a coordinate of time. Together, these four dimensions describe reality fully. In this view, time isn't a flowing river but a coordinate in the map of existence. Events are points in space-time, fixed in there. Location and moment. What changes is not time itself, but our movement through it. When you travel through space, you also travel through time, and vice versa. Einstein's insight dissolved the boundary between where and when. The universe became not a stage where time passes, but a fabric where space and time weave together, inseparable threads of the same cosmic cloth. Einstein changed how we see time forever. Before Einstein, time was thought to be absolute, the same for everyone, everywhere. Newton imagined it as a great invisible clock, ticking steadily throughout the universe. But in 1905, a quiet clerk in a Swiss patent office changed that view forever. Albert Einstein proposed the theory of special relativity, and with it, time lost its universality. He showed that time is not a background stage on which things happen. It's part of the performance itself. Depending on how fast you move, or how strong gravity is where you stand, your time can run differently from someone else's. Time was no longer fixed. It became alive, stretching, bending, and slowing in response to motion and mass. With this revelation, Einstein didn't just change physics. He changed our understanding of reality itself. He showed that time is not absolute. Imagine two people watching the same lightning strike, one standing still, the other racing past on a train. To the stationary observer, the flash seems to happen in one instant. But to the traveler, moving near the speed of light, the sequence of light reaching each end of the train appears different. Both observations are correct, but their sense of when differs. This is relativity. Time is not universal. It depends on the observer's frame of motion. There is no single cosmic clock marking the same rhythm for all. Instead, Each point in motion experiences its own timeline. This realization shattered centuries of assumption. The universe, Einstein revealed, is not built on one absolute now, but on countless personal streams of time, flowing together yet never quite in sync. It flows differently depending on your speed. When you move faster, strange things begin to happen to time. Einstein discovered that motion through space affects motion through time. The faster you travel through space, the slower you move through time. This isn't an illusion. It's built into the structure of space-time itself. Your clock, your heartbeat, even your thoughts would slow relative to someone who remains still. This effect is tiny at everyday speeds, but it grows dramatically as you approach light speed. In a sense, energy and time are two sides of one geometry. Motion through one reduces motion through the other. The universe preserves a constant, the speed of light, and time adjusts to make it so. Thus, speed and time are entwined in a delicate cosmic balance. The faster you move, the slower time passes for you. If you could board a ship that travels close to the speed of light, time for you would crawl. You could journey for what feels like a few years, only to return and find centuries have passed on Earth. This is not fantasy. It's the direct prediction of Einstein's equations. Time dilation has been proven by experiments with atomic clocks on fast-moving planes and satellites. The faster an object moves, the more its time slows compared to a stationary observer. For the traveler, nothing feels different. Their inner clock beats normally. But from the outside, their seconds stretch longer. It is as though motion itself bends the fabric of time, pulling it taut. Every journey through the cosmos is also a journey through differing flows of time. This is called time dilation. Time dilation is one of the most mind-bending ideas in physics, and yet, it's beautifully consistent. Imagine holding two identical clocks. Keep one on Earth, and send the other traveling through space at high velocity. When the traveler returns, the moving clock will have measured less time. Its mechanism, whether mechanical or atomic, actually slowed down relative to the stationary one. This is not mechanical failure, but geometry. Space-time adjusts itself to preserve the constant speed of light. Time stretches to keep the laws of physics the same for all observers. The dilation is real, measurable, and fundamental. Every astronaut, every satellite, every fast-moving particle experiences it. In Einstein's universe, time is elastic, and motion is what stretches it. At near-light speed, seconds can stretch into years. As you approach light speed, the effects of relativity become extreme. A traveler moving at 99.999% the speed of light might experience a single year while thousands of years pass elsewhere. This is the famous twin paradox. One twin remains on Earth, the other travels at near light speed. When the traveling twin returns, they are younger, not by magic, but by the geometry of space-time. The moving twins' path through space-time was different, so their clock ticked fewer times. In this sense, time is not a constant rhythm beating through the universe. It is personal. Each world line, each trajectory, carries its own tempo. As we move faster through space, we move slower through time, as if trading one kind of motion for another in the eternal dance of relativity. Astronauts experience this slightly in orbit. Even at the modest speeds of human spaceflight, time dilation is real. Astronauts aboard the International Space Station travel around Earth at about 28,000 kilometers per hour. Their clocks and their bodies run very slightly slower than those on Earth's surface. Over 6 months, they age about 0.005 seconds less than people on the ground. It's imperceptible, but measurable. Every orbit, they are living a tiny fraction of a second in the past compared to us. The universe doesn't need science fiction to warp time. It happens every day above our heads. The astronaut's experience reminds us that relativity is not just an abstract theory. It's a quiet truth. woven into every motion, every orbit, every heartbeat that takes place under the curve of space-time. Their clocks tick slower than ours on Earth. This small difference in time has practical consequences. GPS satellites, orbiting Earth at high speeds and in weaker gravity, experience both effects: time dilation from motion and time expansion from reduced gravity. Their onboard clocks tick slightly faster due to weaker gravity, but slower due to their velocity. Both must be precisely corrected to keep navigation accurate. Without Einstein's relativity, GPS would drift kilometers each day. This is one of the quiet triumphs of modern physics. A theory once considered abstract now keeps the world's positioning system synchronized. Even a whisper of relativity, a few billionths of a second, can mean the difference between precision and chaos. The universe's geometry governs even the digital maps on our phones. Gravity also bends time. Einstein's second great insight, the general theory of relativity, revealed that not only speed but also gravity affects time. Massive objects like stars and planets curve space-time around them. The closer you are to a mass, the slower time flows. This means that time itself bends under the weight of gravity. A clock on a mountain runs faster than one at sea level because it sits farther from Earth's center of gravity. The difference is minuscule, but real, measured by precise atomic clocks. Near extreme masses, the effect becomes dramatic. Gravity doesn't just pull on objects, it pulls on time itself. The universe is not a flat stage, but a curved landscape where both space and time warp together under the presence of energy and mass. The stronger the gravity, the slower the clock. Imagine standing at the edge of a massive planet. The gravitational pull is immense. Every signal, every heartbeat, every second would slow down compared to someone farther away. To an observer above, your movements appear sluggish. To you, everything feels normal. This is gravitational time dilation. It's not illusion. The very rate at which time passes has changed. Even light leaving the surface of a star loses energy as it climbs out of the gravitational well, stretching into redder wavelengths. Time, in Einstein's universe, is inseparable from gravity's grip. The deeper you fall into a gravitational field, the slower your clock ticks relative to the rest of the universe. In the cosmic sense, gravity is the hand that turns time's dial. Near a black hole, time nearly stops. At the event horizon of a black hole, the boundary beyond which nothing escapes, time reaches its extreme limit. To a distant observer, an object falling toward the black hole appears to slow infinitely, never quite crossing the horizon. Light from it stretches, fading to red, and then to darkness. To the falling object, however, time feels normal. It crosses the horizon and is gone. This difference arises because gravity bends time so strongly that the two perspectives diverge completely. For the outside universe, time near a black hole almost stops. The clock there is frozen, locked in the fabric of space-time. It's as if the black hole isn't just devouring matter, it's swallowing time itself. This is why black holes are called frozen stars. The name frozen star comes from this very effect. From far away, the collapse of a massive star into a black hole appears to slow as it nears completion. Time dilates so intensely that the surface seems to freeze, suspended in an eternal moment. In reality, the star continues its fall, but to outside eyes, its last heartbeat is forever delayed. The black hole becomes a monument to halted time, a region where the geometry of space-time folds in on itself. Within, all paths lead inward, and the concept of time as sequence loses meaning. Black holes are not just gravitational traps. They are the universe's most powerful reminders that time is not fixed, but can stretch, slow, and even pause under the right conditions. Time and space curve together around massive objects. Einstein's genius was seeing That gravity isn't a force pulling downward. It's the curvature of space-time itself. A planet or a star bends the geometry around it, like a weight pressing into a stretched sheet. Objects, including light, move along these curves, not because they're being pulled, but because they're following the straightest possible paths in curved space. Time also curves along with space. The presence of mass slows the rhythm of time, warping not only how things move, but when they move. The universe, then, is not a flat stage with actors upon it. It is the stage and the story. Intertwined. Every mass, every photon, every second of your life is shaped by this cosmic curvature. Light follows these curves, so does time itself. When light passes near a massive object, its path bends, a phenomenon called gravitational lensing. We can see galaxies distorted into arcs by the gravity of even larger clusters. But it's not just space that bends. Time does too. The photons we observe are also climbing through curved time, stretched and delayed by gravity. In this way, the universe acts like a vast lens, not only bending what we see, but when we see it. The light from a distant star may arrive after traveling for billions of years through warped space-time. Every glimmer we witness is a story told across distorted time, a message from the past shaped by the gravity of the cosmos itself. What we call now depends on where we are. In Einstein's universe, simultaneity is an illusion. Two events that seem to happen at the same time for one observer might occur at different times for another, depending on their motion. There is no single universal now stretching across the cosmos. Your present is not the same as the present of a galaxy a billion light-years away. Each region of space-time defines its own surface of now, tilted differently depending on motion and gravity. This destroys the comforting idea of a shared cosmic present, but it also opens something beautiful. Every point in the universe experiences reality in its own way. The moment you live in is yours alone, stitched into space-time's endless tapestry of personal nows. There is no universal present. This is one of Einstein's most unsettling conclusions. There is no single cosmic moment that everyone shares. The universe doesn't experience time all at once. It experiences it locally. Each observer has their own present, and these presents do not align. The concept of now is like a horizon. It depends on where you stand and how you move. For everyday life, the differences are tiny, so we live comfortably with the illusion of shared time. But on cosmic scales, simultaneity dissolves. One galaxy's now could be another's ancient past. The universe is a vast mosaic of overlapping timelines, none privileged, none universal, each a valid slice of the space-time whole. Every observer carries their own timeline. Your life, from birth to this moment, is a continuous thread through space-time, called your world line. It is the path your existence traces through the four dimensions. Every observer, every particle, has its own world line. These threads can cross, interact, and then diverge, but each follows its own rhythm of time. No two are exactly alike, because no two motions are identical. Even the atoms in your body experience slightly different flows of time, depending on their energy and position. The universe, then, is not governed by one single timeline, but by countless intertwined ones, a woven fabric of lives, lights, and motions, each carrying its own private measure of time. The universe is a patchwork of personal nows. Think of space-time as a vast quilt, stitched together from billions of overlapping patches. Each patch represents a different observer's now, a unique slice through the four-dimensional fabric. These slices tilt, twist, and shift depending on motion and gravity, overlapping in some places and diverging in others. What's remarkable is that despite this complexity, the universe remains consistent. Every observer, experiences reality in a way that obeys the same physical laws. The tapestry of personal nows does not tear. It stretches smoothly, connecting every experience in a single, unified geometry. To live, then, is to occupy one small region of that quilt, a private pattern of time, woven seamlessly into the cosmic whole. Time is relative, not fixed, but flexible. In Einstein's cosmos, time is elastic. It bends with motion, slows under gravity, and stretches near light speed. Yet it is never chaotic. The rules that govern its flexibility are precise and elegant, built into the equations of relativity. Time, space, energy, and gravity are all aspects of one unified geometry. This revelation turns our intuitive picture of reality upside down. Clocks do not measure in external flow, they trace their own paths through space-time. What one observer calls a second might not match another's, but both are right within their own frame. The universe does not privilege any single rhythm. Time adapts, flexes, and curves, but always coherently, always according to the same unbreakable law. Yet within that relativity, order still remains. Though time flows differently for everyone, the universe never loses its structure. Relativity does not create chaos, it creates harmony. The laws of physics hold true in every frame of reference. Energy and momentum. Balance. Light travels at the same speed for all, and cause still precedes effect. What changes is only the perspective, not the order itself. Relativity reminds us that difference and unity can coexist. Each observer has their own clock, yet all clocks belong to one cosmic rhythm. Time, then, is both personal and universal, a flexible, living thread that weaves through every corner of existence, binding motion, matter, and meaning into one coherent whole. Time always seems to move forward. From the moment you open your eyes to the second you fall asleep, time feels like an unstoppable current, always flowing in one direction. The present becomes the past, and the future moves closer, step by step. We can recall yesterday, but not tomorrow. We grow older, never younger. Stars ignite, burn, and fade. This forward motion is so deeply woven into existence that it feels fundamental, as if the universe itself were breathing in one continuous direction. And yet, physics tells us something curious. The flow we experience may not be built into the laws of nature. It may be a property of how we, and the universe itself, experience change. The arrow of time, so obvious in daily life, might be the universe's greatest illusion or its deepest truth. We remember the past, not the future. Memory gives time its shape. You can recall what has happened moments behind you, but the future remains hidden. This asymmetry defines your entire experience of reality. Imagine if memory worked both ways. If you could recall tomorrow as easily as yesterday, the world would feel chaotic, unlivable. Our minds, and perhaps our very sense of identity, depend on this one-way record. But why does memory point backward? It's not a trick of biology. It reflects something physical. The past has left traces, records, fossils, memories, photons of light still traveling through space. The future has not yet created its evidence. The arrow of time flows in the same direction as information, from order into history, from potential into memory. This one-way flow is called the arrow of time. The English astronomer Arthur Eddington coined the phrase, the arrow of time, in 1927. He noticed that while the laws of physics are reversible, meaning they don't care which way time runs, the universe clearly isn't. An egg cracks, but never uncracks. Smoke disperses, but never reassembles. There is an unmistakable direction to how things unfold, like an arrow shot through the fabric of reality. This arrow defines the difference between cause and effect, between anticipation and recollection. It gives the universe narrative. Without it, everything would be static, symmetrical, but lifeless. The arrow of time turns existence into a story, where moments follow one another and meaning emerges from motion. But the laws of physics don't care about direction. If you were to film a collision between two billiard balls and then play it backward, you'd find that the motion still makes perfect physical sense. Newton's laws, and even the deeper equations of quantum mechanics, work just as well in reverse. They don't distinguish past from future. The universe's fundamental laws are time-symmetric. Yet our reality clearly is not. Ice melts, but does not refreeze on its own. Waves spread, but do not spontaneously gather. This discrepancy between timeless equations and time-bound experience is one of science's deepest puzzles. The laws themselves do not choose a direction. So where does that direction come from? What makes forward feel different from backward? Equations work the same backward or forward. In pure mathematics, time's arrow vanishes. The symbols care nothing for before or after. You can flip the sign of time in most equations, tt, and the universe they describe behaves perfectly well. Quantum particles don't mind which way time runs. Even antimatter, in a certain sense, behaves like normal matter moving backward in time. So the mystery remains. If the rules of the game are reversible, why does the game itself only play one way? The answer, scientists have learned, is not in the equations themselves, but in the initial conditions of the universe. Somewhere, in its beginning, a direction was set. A boundary, a bias, a starting point, and from that moment, the arrow began to fly. So why does time move one way? To understand the arrow of time, we must look beyond the equations and into the state of the cosmos. Time's direction arises not from how physics works, but from how the universe started, in a state of extraordinary order. Over billions of years, that order has gradually unraveled. This progression, from neatness to messiness, from low entropy to high, is what we experience as forward. Time's arrow is the universe's slide toward disorder. It is the story of structure breaking down, energy spreading out, and possibilities increasing. We move from concentrated beginnings, stars forming, galaxies coalescing, toward diffuse endings. The arrow of time is not drawn by the laws of motion, but by the loss of order. The answer lies in entropy, the measure of disorder. Entropy is one of the simplest and most profound ideas in all science. In everyday language, it's a measure of how disordered or spread out a system is. A tidy room has low entropy, a messy one high. In physics, it's the number of possible microscopic arrangements that still look the same on the surface. Entropy increases when energy spreads, when things mix, when uniformity grows. It's not that the universe wants to become disordered. It's simply that there are vastly more disordered states than ordered ones. Entropy is probability made physical. It explains why eggs break, stars burn out, and why time, in every sense we can feel, moves only forward. Entropy always increases. This principle is called the second law of thermodynamics, and it is perhaps the most unbreakable rule in nature. In any closed system, entropy, the measure of disorder, can never decrease. Order can only be maintained by expending energy elsewhere. Your body stays organized by burning food. A refrigerator keeps things cold by warming the air behind it. Everywhere, entropy grows. This law gives direction to every process in the universe, from the cooling of a star to the fading of a memory. The increase of entropy defines time's arrow. It tells us which way the movie of the universe is playing. Without this principle, there would be no distinction between forward and backward, no past or future, only an eternal, changeless equilibrium. A broken cup doesn't reassemble itself. Picture a cup falling from a table and shattering on the floor. The shards scatter. The sound echoes. Heat spreads through the air. Every fragment, every vibration, increases entropy. It's not impossible for those pieces to leap back together. Physics doesn't forbid it, but the odds are astronomically small. There are countless ways for disorder to exist, and only one for order to be perfect again. That imbalance makes the direction of time overwhelmingly clear. The cup breaks, entropy rises, and the arrow moves forward. Each act of creation, destruction, or decay writes its mark on the ledger of the universe's disorder. The cup's story, like ours, moves one way, from whole to scattered, from simplicity to complexity. Heat flows from hot to cold, never the reverse. If you place a warm hand on a cold surface, heat moves outward, always from higher temperature to lower, never the other way around. This is entropy in action. Energy spreads until it is evenly distributed, and in doing so, defines the direction of time. The flow of heat is the physical manifestation of time's arrow. Every sunrise, every candle flame, every living process is driven by this one-way transfer of energy. The sun burns its fuel, radiating warmth into space. The earth receives it, and life emerges from that imbalance. When energy finally equalizes, when everything reaches the same temperature, time's motion will cease. The arrow stops when the universe runs out of gradients to climb. This gives time its direction. Entropy turns the abstract concept of time into something physical, measurable, inevitable. It ensures that cause precedes effect. That growth turns to decay, and that history moves from order to disorder. The direction of time is not written in the equations, but in the universe's unfolding state. The past is the low entropy condition we remember. The future is the higher entropy condition we cannot yet know. Time is the story entropy tells as it increases, a vast, irreversible narration of transformation. Even your memories are traces of entropy, encoded in the organized structure of your brain, destined one day to scatter. The arrow of time is the handwriting of entropy on the fabric of reality. From order to chaos, from simplicity to complexity. Though entropy is often described as disorder, it also gives rise to complexity. In the early universe, everything was simple, uniform plasma, nearly identical everywhere. As it expanded and cooled, slight fluctuations grew into galaxies, stars, and planets. Entropy increased, but structure emerged. Complexity is not the opposite of disorder, it is one of its paths. As energy spreads, it creates local pockets where order can form briefly, like life, like thought, like you. The arrow of time carries both decay and creation. It is not only the fall into chaos, but also the rise into intricate forms that will eventually dissolve. Time's river erodes mountains, but it also carves valleys of astonishing beauty along the way. The early universe had extremely low entropy. When the universe was born, it was dense, hot, and smooth. But paradoxically, that made it a state of low entropy. Matter and energy were evenly spread, leaving little room for complexity or disorder. Over time, gravity began to clump that smoothness into stars and galaxies, increasing entropy by creating variety. The contrast between that perfectly ordered beginning and the chaotic present is what drives time's arrow. The Big Bang didn't just create space and time, it set their direction. From that pristine, improbable starting point, the universe has been rolling downhill ever since, trading order for diversity, energy for entropy, and simplicity for the endless unfolding of change. As it expands, disorder grows. The expansion of the universe is the grand stage for entropy's rise. As galaxies move apart, energy spreads thinner, stars exhaust their fuel, and matter collapses into black holes. The cosmos is slowly diffusing, losing the gradients that once powered its drama. Each new moment adds to the tally of disorder. The vastness we see in the night sky is the footprint of entropy, the universe growing colder, emptier, yet ever older. Every photon of starlight that escapes into space adds a tiny increment to the cosmic entropy count. Expansion is not just the universe's motion. It is its aging process, its slow, graceful descent toward equilibrium. Every second adds to the universe's entropy. In every tick of every clock, entropy increases. Stars burn hydrogen into heavier elements, releasing heat. Living things consume energy to sustain themselves, spreading disorder to their surroundings. Even in silence, particles vibrate, collisions occur, and the total entropy rises. The arrow of time advances with every breath, every flicker of flame, every fading echo. It is the grand tally of irreversible events. The second law ensures that time never loops back. Every second is a step deeper into cosmic memory. You are living in a universe that constantly writes itself forward, where every action leaves a faint thermodynamic fingerprint that can never be fully erased. Even stars and galaxies obey this law. Entropy doesn't belong only to chemistry or machines. It rules the heavens. Stars live because they are engines of entropy. They convert the concentrated energy of nuclear fusion into dispersed radiation, spreading heat and light through space. Galaxies themselves are structures of rising entropy, vast machines transforming order into complexity and complexity into decay. Even black holes, which seem like the ultimate prisons of stillness, hold the universe's greatest entropy. Their surfaces, their event horizons, encode unimaginable amounts of information. In the end, every cosmic object contributes to the same trend, the slow drift toward thermodynamic balance, the steady, irreversible unfolding of the universe's timeline. When entropy reaches its peak, time may lose meaning. If entropy defines the arrow of time, what happens when there's no more entropy to increase? In that distant future, when energy is evenly distributed and no processes remain to change it, the universe will reach thermal equilibrium. No gradients, no heat flow, no motion. Without change, time itself may lose its meaning. There will be no before or after, just stillness. The ticking of cosmic clocks will fade as all systems settle into sameness. The concept of duration depends on transformation. Without events, there is no time to measure. When the universe stops changing, time's arrow will have flown its final course into silence. The universe will reach heat death. Physicists call this ultimate stillness, the heat death of the universe. It does not mean fiery destruction, but the opposite, the extinguishing of all usable energy. Stars will have long since burned out, galaxies drifted apart. Black holes evaporated into faint radiation. The cosmos will be vast and cold, its temperature nearly uniform everywhere. No engines will run, no processes will unfold. Entropy will be maximized. In this frozen eternity, time will no longer have a direction, because nothing will happen to mark it. The universe will not die in fire, but in endless calm, the final equilibrium of all that ever was. All processes will stop, no change, no time. When the last particle ceases to collide, when even radiation has stretched to nothingness, the story of time will pause. Change defines time. Without it, the word becomes meaningless. In this ultimate stillness, the universe will remain vast, dark, and nearly empty, yet timeless. It will not decay further because there will be nothing left to decay. Physicists sometimes call this the quiet eternity, a realm where existence persists but evolution ends. It is the final chapter of the arrow's flight, the point where motion, heat, and causality dissolve into equilibrium. Beyond it, the idea of time itself might simply fade away. The arrow will fade into stillness. Time began as a burst, a sudden expansion of energy and order. It may end as a whisper, a slow settling into perfect calm. The arrow that began with the Big Bang will, one day, come to rest. Yet, even then, its memory will remain, written in the relics of radiation, in the faint afterglow of creation. The stillness to come is not destruction but transformation, the universe completing its long journey from motion into peace. In that silence, perhaps something deeper than time will remain, the eternal presence from which time itself once arose. The arrow's flight ends not in emptiness, but in quiet completion, a return to the timeless source. The human brain doesn't sense time directly. Unlike sound or light, time has no organ, no receptor, no nerve that detects it. The brain doesn't hear time or see it, it infers it. What we call the perception of time is actually the mind's ability to compare changes, the rhythm of speech, the beating of a heart, the shifting of light. Every sensation arrives in fragments, and the brain weaves them into sequence. Time, for us, is the brain's quiet calculation of what changed and how long ago. It is a reconstruction, not a raw input. This is why time feels elastic. Why minutes can stretch or vanish depending on our focus. The brain does not record time. It builds it, moment by moment, as an internal map of change. It measures sequences of change. Every experience you have is built from a chain of sensory events. The brain stitches these events together into continuity, a flowing movie made of still frames. When the spacing between events widens, time feels slow. When the frames come rapidly, time feels fast. The mind is always comparing. The interval between footsteps, the rhythm of breath, the flicker of light. This is how we feel. Duration, not through an inner clock, but through pattern recognition. The neurons responsible for timing are distributed across the brain. In the cerebellum, the basal ganglia, the prefrontal cortex. Together, they measure intervals, like musicians sensing tempo. Time, for the brain, is rhythm, and we are instruments constantly keeping beat with the world. Our memories give time its flow. The past feels real because it leaves traces in memory. Without memory, there would be no before, only a single, repeating instant. It is memory that strings moments into a story, giving life its continuity. Each recall is a reactivation of old neural patterns, layered over the present. The flow you feel when you think of time passing is not external. It is the mind, revisiting snapshots, comparing them, and inferring motion. Memory transforms discrete experiences into a river. In that way, time's flow is not something we observe, it's something we create. We are the storytellers of our own chronology, turning static events into a living sense of duration. Without memory, there would be only an eternal present. Imagine existing with no recollection of what came before. No past, no sequence, just the constant arrival of the now. This is what amnesia or certain neurological conditions can feel like, a perpetual reset of experience. Without memory, the sense of flow disappears. Time collapses into a single, unanchored moment. For such a mind, there is no aging, no narrative, only awareness. In that way, the experience resembles deep meditation, or the moment between waking and sleep, where time loses its boundaries. Without memory, consciousness remains, but the timeline vanishes. Perhaps eternity, in its purest sense, is exactly that, awareness without sequence. Infants live in this timeless state. For newborns, the world is pure sensation, sound, warmth, touch, with no order or expectation. They do not yet distinguish yesterday from tomorrow. Each cry, each smile, each heartbeat happens in the eternal now. Neuroscientists suggest that the brain's temporal networks mature slowly, building a sense of continuity over months and years. Childhood, then, begins in a timeless ocean. Time is learned, not perceived. As infants grow, they start to notice patterns. The mother's face returns. The sun sets and rises, sleep follows feeding. From these cycles, time emerges. The first clock is not on a wall. It is in the infant's awareness of repetition. Out of chaos, rhythm is born. Emotion alters time perception. The brain's sense of time is deeply tied to emotion. Fear, excitement, boredom, each reshapes how long a moment feels. When adrenaline floods the system, attention sharpens, memories record in greater detail. Later, when replayed, those moments seem to have lasted longer. Fear slows time because the brain samples the world more densely. Joy, on the other hand, blurs detail. Attention flows freely, and time seems to fly. The passage of time is, in part, the passage of feeling. The more emotionally charged a moment, the more deeply it imprints itself on our internal timeline. Our hearts are the metronomes of our experience, each emotion bending time's rhythm to its own tempo. Fear slows time, joy speeds it up. When danger strikes, your body enters survival mode. Every fraction of a second matters. The amygdala, your brain's emotional sentinel, floods your system with alertness. You notice everything, sounds sharpen, movement slows, and time stretches. It's not that time actually slows, your perception expands. The brain is processing more information per unit of time, creating the illusion of slowness. Conversely, in joy or excitement, we take in less detail. The brain moves lightly, efficiently, and time feels quick. Hours vanish at a party, yet minutes crawl in anxiety. Time is not constant in our experience. It breathes with our emotions. Each heartbeat rewrites its pace. Waiting feels longer than moving. When you are still, focused on the passage of time itself, each second becomes heavy. Waiting magnifies awareness. In contrast, movement, both mental and physical, distracts the mind's clock. This is why a journey feels shorter on the way back than on the way there. When your mind has something to do, time collapses. When you count each second, it expands. Our brains measure duration not by clocks, but by events. The fewer events we process, the longer time feels. So, when we wait, deprived of stimulation, the brain fills the silence with expectation, and in doing so, stretches time's fabric until it almost hums. Novelty stretches our sense of time. The first time you visit a new place, every detail demands attention: sights, sounds, textures, smells. Your brain takes in more information, storing vivid memories. Later, that experience feels longer, richer, as though time expanded. This is the holiday paradox. New experiences slow subjective time in the moment, but later seem longer in retrospect. Familiarity, by contrast, compresses time. When you repeat the same route, the same routine, the mind stops recording details and the days blur. Novelty gives the brain something to measure against. It populates your timeline with texture. To lengthen your life, even without more years, seek newness. Time stretches where curiosity lives. Routine compresses it. Monotony is a quiet thief of time. When days repeat, the brain stops encoding new memories, and entire weeks seem to vanish. Routine feels short because there's little information to distinguish one moment from another. This is why childhood summers feel endless, while adult years seem to slip away, not because time changes, but because we stop changing. The fewer new experiences we record, the shorter time seems in memory. Routine creates comfort, but it also erases detail. The clock still ticks, but the mind skips beats. In that way, the fastest years are often the most predictable ones, a paradox of peace and loss. That's why childhood feels longer. When you are young, everything is new. Each sound, taste, discovery is fresh data for the mind. The brain, learning rapidly, stretches each day with vivid detail. The first snow, the first friendship, the first heartbreak. Every event feels monumental because it fills the timeline with information. As you age, the novelty fades. Days grow more similar, and the brain compresses them. It's not that time speeds up, it's that memory density decreases. Childhood feels long because it's packed with firsts. Adulthood feels short because it's filled with repeats. The measure of time is, in part, the measure of wonder. And adulthood feels faster. With familiarity, the years condense. Responsibilities, routines, and repetition blur the edges of experience. Adults live by schedules, not discoveries. The brain, having mastered its world, stops paying attention to the small miracles. Days pass unnoticed. Time slips through memory's sieve. But every so often, in travel, in love, in grief, awareness returns, and time expands again. Adulthood doesn't have to feel short. It simply requires newness to slow it down. Curiosity, creativity, and reflection are acts of temporal resistance. They remind us that while we can't change the clock, we can change how we experience its rhythm. Dreams have their own time, compressed and fluid. When we dream, the brain enters a world unbound by real clocks. Hours of story can unfold in seconds of sleep. Events leap without cause or continuity. Time in dreams is subjective, a construct of imagination, not physics. Neurologically, the prefrontal cortex, responsible for logical sequence, quiets down, allowing scenes to merge and flow freely. The dream world follows the logic of emotion, not chronology. That's why you can age, die, and be reborn in the same dream without noticing. In the theater of the sleeping mind, time stretches and folds, unconcerned with gravity or motion. The dream is the brain's nightly rebellion against linear time. Sleep is the mind stepping outside linear time. When you drift into sleep, consciousness detaches from external sequence. The sensory gates close, the world dims, and the internal clock loses its anchor. Hours can pass without awareness, a jump cut in the film of life. Sleep is biological time dilation. The brain cycles through patterns of activity, REM, deep sleep, light sleep, but the self does not track them. We enter a realm where time is felt as restoration, not measurement. Sleep reminds us that time is not only something to manage, but something to surrender to. It is the universe's way of folding us briefly outside of its flow, then gently returning us to it. Meditation can dissolve time awareness. Deep meditation alters how the brain processes sequence and self. Neural networks tied to temporal awareness, especially in the parietal cortex, quiet down. The boundary between moments softens. Practitioners often describe a sensation of timelessness, of existing in a single, boundless now. In such states, the sense of duration fades, and awareness becomes continuous rather than divided. This isn't supernatural, it's neurological. The brain, freed from the constant comparison of before and after, rests in pure presence. Meditation is not the escape from time. It is the recognition that time itself arises from thought. When thought stills, so does time. Consciousness creates its own timeline. Your experience of time is a byproduct of consciousness itself. The brain integrates perception, emotion, and memory into a unified narrative, a moving now. This integration has a tempo, about a few hundred milliseconds per cycle. That's the length of the window of the present, the time it takes to become aware of something. Beyond it, the past and future are mental constructions. Consciousness is the continuity between these windows, stitched together like frames in film. The illusion of motion, of flow, arises from that stitching. In this sense, time is consciousness experiencing itself, awareness unfolding in sequence. Some physicists think time is an illusion. In certain interpretations of modern physics, Particularly in quantum gravity, time may not exist as a fundamental property. The universe might be timeless at its core, with what we call time emerging from relationships between events. The equations describing the cosmos can work perfectly without a variable for time. They simply describe configurations of reality. From this perspective, the flow of time is a feature of perception, not physics. We experience change as sequence because consciousness imposes order on chaos. Time may be the mind's way of navigating a universe that, in its essence, is perfectly still. The brain may stitch moments together into continuity. Psychologists have found that our sense of now lasts about 3 seconds. Within that window, events are merged into a single perceptual moment. The brain collects fragments, sights, sounds, feelings, and binds them before letting them fade into memory. Between these windows are tiny gaps we never notice. Our minds fill them seamlessly, like frames in a movie. In truth, consciousness flickers, but it feels smooth because the brain edits out the pauses. Time, for us, is this stitching, the illusion of unbroken flow. We are, in effect, living inside the film reel our minds are projecting, frame by frame. But even illusions reveal deeper truths. If time is an illusion, it is a useful one that enables motion, memory, and meaning. Illusions, after all, are not lies, they are interpretations. The mind's version of time allows us to act, plan, learn, and love. Without it, life would be a single static instant. The illusion reveals that perception is creative, that consciousness doesn't just receive reality, but shapes it. Perhaps time, like color or sound, is not a property of the universe, but a translation of it. The illusion is the bridge between the timeless and the living, between what is and what becomes. Time may exist because we need it to. Without time, there would be no growth, no sequence, no story. Our minds depend on it to make sense of change, to measure existence in digestible steps. Perhaps time, as we know it, is a mental scaffold, a way for finite beings to experience the infinite without being overwhelmed. We need time so that eternity can unfold gently, one heartbeat a day. Time. The brain's version of time may not be the universe's truth, but it is our own. It allows us to wake, to remember, to hope, to dream. In that sense, time is not only physics, it is compassion, the universe slowing itself down so we can understand it. Einstein once said, "The distinction between past, present, and future is an illusion." When Albert Einstein wrote those words, he wasn't being poetic, he was being literal. To him, time did not flow the way we experience it. In the mathematics of relativity, the universe is a single, four-dimensional structure, space and time bound together into one continuum. Every event, every birth, every star's ignition, every quiet breath you take, already has a place within that structure. The past, the present, and the future all coexist. What we call the passage of time is merely our movement through this vast geometry. Einstein's illusion isn't deception, it's perspective. We see a sequence because consciousness travels line by line through a script that is already complete. In relativity, all moments exist equally. Relativity abolishes any privileged now. What is the present for one observer may be the past or future for another, depending on motion and gravity. This means that all points in time exist with equal reality. The moment you are reading this, the moment you were born, and the moment of your last breath, all coexist within spacetime. None is more real than the other. They simply occupy different coordinates. The universe is not a film playing forward, but a reel already developed from beginning to end. We do not watch the movie. We are the characters, moving frame by frame through a story that, from outside time, already exists in full. This view is called the block universe. Physicists call this idea the block universe, a single, timeless entity containing all of space and all of time together. Imagine the entire history of the cosmos as one solid shape, from the Big Bang to the heat death. Every event embedded like crystal layers in a vast jewel. Nothing happens within the block, everything simply is. What we experience as motion and change is the act of consciousness tracing a path along the structure. The block doesn't grow or evolve. It doesn't wait for the future to arrive. The future is already there, silently existing alongside the past, waiting for us to perceive it. Imagine space-time as a loaf of bread. To picture the block, think of a loaf of bread. Each slice is a moment in time, thin but complete, containing the entire universe as it existed at that instant. Together, these slices form the loaf, all moments stacked side by side, creating a solid continuum. When we say time passes, what really happens is that our consciousness moves from one slice to the next. The loaf doesn't change, but our attention shifts through it, giving the illusion of flow. The past slices remain. The future ones already exist. The universe, as a whole, is the loaf, still, complete, eternal, while we, the observers, are the knife moving gently through it. Each slice is a moment. Each moment of your life. This breath, this heartbeat, this thought, is one slice in the block. Every molecule in your body, every photon around you, exists at a particular coordinate in space-time. That coordinate never vanishes. It remains part of the eternal geometry, as real as any star in the sky. From our limited perspective, we can only inhabit one slice at a time, but in the structure of space-time, all of them coexist. The laughter of your childhood, the steps you will take tomorrow, both exist as slices in the same cosmic loaf. You are, in a sense, everywhere you have ever been, and everywhere you ever will be. All slices exist together, timelessly. In the block universe, nothing truly comes into being or fades away. All slices of time, every configuration of matter and energy, coexist in a timeless whole. The universe is not moving from the past to the future. It simply is. What we call becoming is the act of observing one region of the block rather than another, just as all places exist simultaneously in space. All moments exist simultaneously in time. Eternity is not endless duration. It is all durations existing together. The block is not frozen. It is complete. Stillness and fullness are the same thing. We experience the loaf one slice at a time. Our consciousness, bound by perception and memory, can only experience one slice after another. We move through the loaf in sequence, like a needle threading through fabric. This gives rise to the sensation of time flowing, a one-way progression from past to future. But the motion is within us, not the universe. The slices are already there, arranged in their eternal order. Our awareness scans them sequentially, constructing the illusion of motion. Just as a film projector brings still frames to life, consciousness animates the block. What we call living is the act of reading reality one frame at a time. The future already exists, we just haven't reached it. If all slices of time exist simultaneously, then the future is as real as the past. Every event that will ever happen already has a coordinate in the block. To us, the future seems open because we haven't yet experienced those slices. From a timeless perspective, though, they are already part of the structure, waiting for us to arrive. This doesn't mean we can predict them, only that their existence is assured within the total geometry. The block universe contains every possibility realized. Our journey through it gives us the gift of discovery, the joy of unfolding what, in some deep sense, already is. The past is still there, we've simply moved on. The moments you've lived are not gone. They remain fixed in their coordinates, forever part of space-time. The child you once were still exists in that earlier slice, smiling, breathing, unknowing of what comes next. The people you've lost are not erased. They are simply located in earlier pages of the cosmic book. You have moved forward, but the chapters remain. To remember is to glance back through the block, revisiting coordinates you no longer inhabit. The past endures, not as fading memory, but as a permanent feature of the universe's structure. In the block universe, nothing truly disappears. It simply ceases to be your current slice. In this model, time doesn't flow, we do. The river of time, in this picture, does not run at all. The river is the landscape, and we are what moves. Time does not carry us forward. Consciousness travels through space-time like a traveler crossing a map. The illusion of flow is generated by motion through this dimension. To ask why time flows is to ask why we move, why our awareness slides from one frame to the next. The answer may lie in the way memory links slices, creating continuity. We are not carried by time's current. We are the current, moving across a sea that has always been still. The universe itself is timeless. If the block universe is correct, then time is not something the universe experiences. It is something contained within it. From outside the block, there is no before or after, no start or end. The entire cosmic history exists at once, like a sculpture seen from all sides. The universe, in its entirety, is a timeless object, unchanging yet infinitely detailed. Within it, beings like us experience sequence because our consciousness traces one narrow path through its structure. From the outside, there is no motion, no ticking clock, only the eternal completeness of space-time. We are like travelers reading a fixed story. Imagine a novel, already written from first page to last. The reader moves through it line by line, discovering events in order, though all of them already exist within the book. In the block universe, we are that reader. The universe is the book. Each moment of your life is a sentence already inked on the page. You can't skip ahead or rewrite it, but you can experience it fully. The joy, the sorrow, the wonder, as you move through it. Existence is the act of reading, not writing. From within the story, time feels alive. From outside, it is already told. Free will still exists, as part of the block structure. If every event already exists, does that mean we have no freedom? Not necessarily. In the block universe, your choices are as real as the consequences they lead to. The decision and its outcome coexist within the structure, bound by the same laws of consistency. Free will, in this view, is the internal experience of moving through your path. The lived reality of choosing what, in the timeless geometry, is already part of you. You are not a puppet. You are the consciousness exploring one thread of possibility woven into the whole. Freedom is not in changing the block. It is in being aware within it. Every decision is already written, yet lived freely. The paradox of the block is that everything is predetermined and yet authentically experienced. When you decide to speak, to love, to change, that choice is part of the space-time fabric. It exists alongside its causes and effects. But the feeling of decision, the sense of agency, is still real because it's woven into your particular world line. From within the story, you are free. From outside, the story is whole. Both perspectives are true, and neither cancels the other. Determinism and freedom are not enemies in the block universe. They are different ways of looking at the same unbroken pattern. Our consciousness moves along the block. Your awareness is not spread across the whole structure. It moves through it, moment by moment, like a light scanning across a vast painting. This motion gives rise to the sense of time passing. Consciousness is the traveler. Space-time is the landscape. As you move, you illuminate one small region of existence, the present. Memory is the light that lingers on previous regions. and anticipation is the faint glow of those ahead. Perhaps what we call life is this luminous journey, awareness sliding through a timeless universe, giving warmth and meaning to each frozen frame. It touches. Death may be simply the end of the path, not the end of existence. In the block universe, death is not annihilation. It is the boundary of a world line. The final slice of consciousness exists as permanently as the first. Your entire life, from beginning to end, is an unbroken path through space-time, complete and eternal. To those still moving, you appear gone. But in the structure itself, you remain, every laugh, every heartbeat, every moment preserved. Death, then, is not disappearance but stillness. It is where the traveler stops moving, while the landscape remains intact. Nothing is lost. The path simply no longer advances. In eternity, every life remains whole. The block contains all of space-time, a complete whole. The block universe holds every galaxy, every timeline, every instant, from the first burst of creation to the last photon fading into silence. It is not expanding or contracting. It is complete. What we perceive as cosmic evolution is simply the structure's internal relationships viewed from within. The Big Bang, the birth of stars, the rise of life, all are coordinates on one timeless object. In that sense, the universe is not something unfolding in time, but something existing in its entirety beyond time. It is a masterpiece of geometry, a four-dimensional sculpture of everything that has ever been. This is sometimes called eternalism. Philosophers call the block view eternalism, the belief that past, present, and future all exist equally. It contrasts with presentism, which holds that only the present is real. Eternalism aligns closely with relativity, giving physical meaning to all points in space-time. It offers a strange comfort. Even as moments fade from experience, they remain within the eternal structure. Every smile, every dawn, every passing storm exists forever in the coordinates it once occupied. The universe, then, is not fleeting. It is eternal in a way deeper than immortality. Everything that has been is still here, simply not being perceived. It challenges our everyday sense of now. The block universe unsettles our intuition because it erases the privilege of the present. There is no single, universal now. No moving spotlight sliding across time. All nows exist together. What we feel as the present is just the slice currently illuminated by consciousness. The future is not waiting to happen. It is already part of the block. The past is not gone. It still exists. Our sense of immediacy, the heartbeat of being, is how awareness experiences one coordinate at a time. To the universe, all moments are equal. To us, one of them shines brighter, the one we call now. But it gives comfort. Nothing is ever truly lost. Perhaps the most beautiful aspect of the block universe is its serenity. In a cosmos where all events coexist, nothing truly disappears. Every joy, every sorrow, every act of love is preserved. Forever part of spacetime's fabric. The people you miss, the moments you wish to relive, they still exist, resting in their coordinates, untouched by time's erosion. From within the flow, life feels fragile and fleeting. From beyond it, everything is eternal. The block universe doesn't promise immortality of the soul, but it offers a gentler truth in the geometry of existence. Nothing is ever truly gone. It simply rests forever where it always has been. If time is a dimension, can we travel through it? If space has 3 dimensions, and we can move freely through them, then why not through time the 4th? It's a question that has haunted both scientists and dreamers. We already travel through time constantly, 1 second per second, always forward. But could we change direction? Could we move faster, or even backward? If time is truly a coordinate in space-time, Perhaps there's nothing to prevent such motion except our limited technology, or our limited understanding. To travel through time would mean to navigate space-time itself, not moving within it, but bending it. It's an idea that sounds like fantasy, yet its seeds lie in the mathematics of relativity itself. Einstein's equations say, maybe. When Einstein published his field equations of general relativity, he didn't intend to invent time travel, but the solutions to those equations, the geometry of space-time itself, contain surprising possibilities. Under certain conditions, the fabric of space-time can twist, fold, or connect in ways that allow shortcuts between points not just in space, but in time. Relativity doesn't forbid such paths. It allows them, carefully, conditionally. Whether nature actually permits them is another matter. In theory, the universe can bend time into loops. In practice, it may protect its own timeline. Still, the math leaves a door ajar, and that crack of possibility has fueled imagination ever since. Wormholes could connect distant points in time. A wormhole is a theoretical tunnel linking two regions of space-time, a shortcut through the cosmic fabric. First proposed by Einstein and Nathan Rosen, it's sometimes called an Einstein-Rosen bridge. If one mouth of a wormhole could be accelerated or placed in a different gravitational field than the other, time dilation would cause them to age differently. Step into one mouth, and you could emerge not only light years away, but years, or even centuries, apart in time. The challenge, of course, is that wormholes may be unstable, collapsing instantly without exotic matter to hold them open. Still, they remain one of the most tantalizing possibilities for traveling through time. A rotating black hole might twist spacetime into loops. In 1963, mathematician Roy Kerr discovered a solution to Einstein's equations describing a spinning black hole, now called a Kerr black hole. Unlike a static one, its rotation drags spacetime around with it, twisting it into complex shapes. Theoretically, this could create paths that loop back on themselves, allowing a traveler to return to their own past. These loops, called closed time-like curves, exist in the mathematics of relativity, though whether they exist in reality remains unknown. Inside the equations, time can bend, stretch, and circle. In nature, gravity might be strong enough to make the impossible, at least for a moment, real. These loops are called closed time-like curves. A closed time-like curve, or CTC, is a path through spacetime that returns to its starting point in both space and time. Follow it, and you would arrive back at the exact event you left, the same coordinates, the same moment. It's the purest form of theoretical time travel. Solutions allowing CTCs appear in several models of relativity, around rotating black holes, in wormhole geometries, even in hypothetical structures called Tipler cylinders, infinitely long rotating masses that drag time into circles. They show that physics does not absolutely forbid time travel. It simply makes it extraordinarily difficult, perhaps intentionally so. They allow return to the past, at least mathematically. Mathematically, closed time-like curves are consistent within Einstein's equations. Nothing breaks, no paradox emerges, until you try to add observers and choices. In pure geometry, loops in time are just shapes. But for beings who remember, decide, and act, the consequences become tangled. If you could revisit a point in your own past, could you alter it? Would that change ripple forward to the present? Or would the universe simply rewrite itself to keep everything consistent? The math allows the loop, but it doesn't answer the question of meaning. Geometry may be forgiving, causality may not. But paradoxes arise. The moment we imagine traveling backward in time, we encounter contradictions. What if you went back and prevented your own journey? What if a message sent to the past erased the need to send it? These are the classic time travel paradoxes, and they expose how deeply cause and effect define our universe. In normal experience, effects follow causes. In a time loop, the two can overlap. The cause might depend on its own result. The paradox isn't just logical, it's existential. If you could rewrite your past, what happens to the version of you who lived it? Can two versions of reality coexist, or does one erase the other? The grandfather paradox questions causality. The most famous of all paradoxes is the grandfather paradox. Suppose you travel back in time and prevent your grandfather from meeting your grandmother. Then your parent and you would never exist. But if you never existed, who made the trip in the first place? The loop collapses under its own logic. The paradox highlights a fundamental tension. If the past can be changed, consistency unravels. The universe, as we know it, depends on causality, the rule that every event has a cause that precedes it. If time travel allows cause and effect to switch places, then everything we understand about reality dissolves. Could you erase your own existence? In science fiction, this idea is irresistible and tragic. The notion that you could undo yourself, that existence itself could fold in contradiction, is powerful storytelling. But physics may be kinder. Most theories suggest that true paradoxes cannot occur. The laws of the universe are self-consistent. They don't permit contradictions. If you could go back, something would intervene, perhaps chance, perhaps probability, to prevent the erasure. The gun jams, the event misfires, the meeting still happens in another way. Reality seems to prefer coherence, even at the cost of freedom. The universe, it appears, protects its own timeline. Some theories say the universe forbids such loops. Physicist Stephen Hawking once proposed the chronology protection conjecture, the idea that the laws of nature prevent time travel on any scale where paradoxes could arise. According to this view, feedback from quantum effects near a time loop would destroy it instantly. The universe censors violations of causality before they can occur. It's as if space-time defends its own integrity, sealing itself against contradictions. Time loops might exist mathematically, but in reality, the energy required to maintain them would trigger instability so violent that the passage collapses before any traveler can use it. The universe, Hawking suggested, has a built-in guardian of causality. Others say the timeline would self-consistently adjust. Another possibility is that time travel is allowed, but paradoxes aren't. This is the essence of the Novikov self-consistency principle. It proposes that any event that would create a contradiction simply has zero probability of occurring. The timeline adjusts itself to remain coherent. If you travel to the past, you can interact with it, even influence it, but never in a way that changes what has already happened. You might cause the very events you came back to prevent. Your interference becomes part of history, not a rewrite of it. The loop closes smoothly. The universe remains consistent, and paradox dissolves into destiny. This is the Novikov principle, no contradictions allowed. Under the Novikov principle, the universe behaves like an author editing its own story to eliminate plot holes. Every action you take while traveling through time becomes part of the timeline itself. You were always meant to do it. The past you visit already includes your arrival. In this view, time travel doesn't violate causality. It fulfills it. Free will remains, but only within the boundaries of what is self-consistent. The idea may feel fatalistic, but it preserves the beauty of logic. Even in the strangest geometries of space-time, the universe refuses to contradict itself. Time travelers might still act, but never change history. Imagine stepping into the past and realizing that everything you do there was already part of the record. The note you dropped becomes an old letter found decades later. The warning you gave becomes the very reason events unfolded as they did. You don't change the past, you complete it. The traveler becomes the missing piece that makes the timeline whole. It's an eerie form of destiny, freedom without alteration. In such a universe, the past is flexible only in appearance. The story has already been written. You're simply walking through the pages that were waiting for your footprints. Quantum mechanics adds new twists. At the quantum scale, time behaves even more strangely. Particles can appear to affect their own past states through interference patterns. Experiments show that measurements made in the present can influence outcomes that seem to have already occurred, a phenomenon called quantum retrocausality. These effects don't allow human-scale time travel, but they hint that causality is not as rigid as we think. In quantum physics, the past and future are entangled. They form a web of possibilities that only solidify when observed. Time, at this level, is less a river and more a shimmering field, responsive, uncertain, and profoundly connected. In some views, each change creates a new branch, a new timeline. To escape paradoxes, many physicists and philosophers turn to the many-worlds interpretation of quantum mechanics. In this view, every possible outcome of every event exists in its own parallel universe. If you travel back in time and make a change, you don't alter your original timeline. You create a new branch where the change has taken effect. The original version continues untouched. Reality becomes a vast, branching tree of histories. You can visit the past, but not your past. You can change the world, but only in a new one. The cost of time travel is infinite multiplicity. This is the many-worlds interpretation, proposed by physicist Hugh Everett in 1957. The many-worlds theory suggests that the universe splits continuously with every quantum event. Each branch represents a different outcome. Every decision, every coin flip, every heartbeat spawning countless versions of reality. In this framework, time travel doesn't disrupt causality. It simply shifts you to a different branch. The traveler's original world remains unchanged, while a new universe unfolds with the altered conditions. The paradox disappears, replaced by infinity. Every possibility happens somewhere, and the traveler merely steps between them, like a reader flipping to another chapter in an endless book. Each decision spawns another universe. Think of every choice you've ever made, and every one you didn't. In the many-worlds picture, each of those decisions gives rise to a new universe. In one, you turned left, in another, right. In one, you spoke. In another, you stayed silent. These branching worlds all exist simultaneously. Each as real as the next. Time, in this view, is not a line but a fractal, endlessly dividing, creating copies upon copies of reality. If you could move between them, you'd find infinite variations of yourself, each following a different thread of destiny. The universe, then, is not one story, but an infinite library of them. So perhaps every possibility exists somewhere. If the many worlds idea is true, then nothing is ever lost, only diverged. Every outcome that could happen does happen, somewhere in the cosmic branching. Every unchosen path still exists, followed by another version of you. Time travel, then, is not movement through a single timeline, but navigation across this vast multiverse. Instead of rewriting history, you step sideways into a different one. Every possibility is realized somewhere. Every dream lived in some distant version of reality. Infinity, in this sense, is not empty. It's filled with the totality of all that could ever be. In that sense, time travel happens across realities. If moving backward in your own timeline is impossible, perhaps time travel happens in another form, by shifting between branches of the multiverse. Each shift is not a return, but a relocation. The traveler doesn't undo the past. They enter a version of it where the conditions differ. It's not paradox, but plurality, an endless field of alternate presence. We may never build a machine to pierce those boundaries, but in principle, quantum mechanics suggests they're real. Somewhere, perhaps, every possible yesterday and tomorrow coexist, and movement between them is simply another kind of journey. The multiverse could be the true time machine. In the end, the most profound form of time travel may not be through loops or wormholes, but through existence itself. If reality branches infinitely, then every moment, every decision, every breath already creates a new universe. Each is a new timeline, a fresh version of reality unfolding in its own direction. We are all, in a sense, time travelers, stepping between possible worlds with every choice we make. The multiverse, if it exists, is not a collection of destinations. It is the living map of time's full potential. In it, every past endures, every future awaits, and every version of you continues on, somewhere among the endless stars. The universe has its own timeline, cosmic time. When cosmologists speak of cosmic time, they mean the grand universal clock that began with the Big Bang. It's not the ticking of a watch or the orbit of a planet. It's the age of the universe itself, measured from the moment everything began to expand. Unlike local time, which bends under gravity and motion, cosmic time assumes a vast average, a shared rhythm across all galaxies that drift with the universe's expansion. It is the master timeline of existence, the pulse of creation itself. Every atom, star, and being is born within this same unfolding sequence, all participants in the same cosmic clock. It began 13.8 billion years ago. According to observations of the cosmic microwave background and the movement of distant galaxies, our universe began about 13.8 billion years ago. That number isn't arbitrary. It comes from measuring how fast space is expanding, the Hubble constant, and tracing it backward. In that unimaginable beginning, time, space, and energy emerged together. The universe didn't appear in time. Time appeared with the universe. Every second since then is a continuation of that expansion, each moment a ripple from that first instant. 13.8 billion years later, we are still feeling the echo of creation with every heartbeat, every sunrise, every ticking second. Each galaxy shares roughly the same cosmic age. No matter where you are in the universe, the cosmic clock reads nearly the same. Every galaxy, from the Milky Way to the farthest quasar, began its journey at the same cosmic dawn. The stars may differ in age, but the space-time that carries them is the same age everywhere. It's as though the entire universe was born in one breath, expanding evenly in all directions. From any vantage point, it seems that everything is rushing away from you, but in truth, it's space itself stretching equally everywhere. The cosmic timeline is shared, not local. We all drift through the same ancient rhythm. Expansion of space defines the universe's clock. Cosmic time flows with expansion. As the universe grows, the distance between galaxies increases, and so does the measure of time since the beginning. The expansion rate acts like the ticking of a vast clock, each beat measured by how far light travels through stretching space. This expansion isn't happening into anything. It's the fabric of reality itself enlarging. The more the universe expands, the older it becomes. If, one day, expansion stops, cosmic time itself might also halt. Not because clocks would stop ticking, but because the geometry that defines later and earlier would cease to grow. Light carries history across billions of years. Every beam of light is a messenger from the past. It moves at a finite speed, about 300,000 kilometers per second, and though that seems infinite to us, across cosmic distances it becomes a delay. Light from the sun takes 8 minutes to reach Earth. From the nearest star, over 4 years. From the farthest galaxies, billions. Each photon you see tonight began its journey long before life on Earth existed. When you gaze at the stars, you are not seeing them as they are. You are seeing ancient memories, the ghosts of what they once were. The night sky is the universe's diary, written in light. Looking far means looking back. In astronomy, distance and time are the same thing. The farther we look, the older the light we see. A telescope doesn't just magnify space, it peers into the past. When we observe galaxies billions of light years away, we're witnessing the universe as it was billions of years ago. Each observation is a time capsule, showing us different chapters of cosmic evolution all at once. Some galaxies we see may no longer exist. Their light is still traveling toward us, carrying their final image. The farther our instruments reach, the deeper we look into the origins of everything. The night sky is a time machine. Every starlit night is a journey through history. The faint glow overhead is not the universe now, but the universe then, a living museum of ancient light. Each twinkle is a story that began long ago, still unfolding as photons complete their epic voyage. The Andromeda Galaxy you can glimpse with your eyes shines from 2.5 million years in the past, when our ancestors first learned to use tools. To stargaze is to travel through time. The sky is a living archive of creation, and every look upward is a communion with history billions of years deep. Every star you see is already gone or changed. The stars you admire are never quite what they seem, because their light takes years, or centuries, or millennia, to reach us. We always see them as they were, not as they are. Some may have already burned out, collapsed, or gone supernova, their true fates still hidden by distance. Others have aged, shifted color, or birthed new worlds, while their younger light continues to arrive here. The night sky is a ghostly reflection, a gallery of what once existed, frozen in transit. To look at the stars is to read the universe's memories, flickering across time. The cosmic microwave background is the oldest light. The faint microwave glow that fills the universe, invisible to our eyes but detectable by radio telescopes, is the cosmic microwave background, or CMB. It's the afterglow of the Big Bang itself, released when the universe was just 380,000 years old. Before that, space was opaque, a hot plasma, where light couldn't travel freely. When the cosmos cooled enough for atoms to form, photons were finally released, spreading in all directions. Those same photons still wash over us today, stretched into microwaves by billions of years of expansion. The CMB is the oldest photograph ever taken, a baby picture of the universe. It's a fossil from 380,000 years after the Big Bang. The CMB is a relic, a fossil of temperature and density from the infant cosmos. It carries tiny fluctuations, slight differences in warmth that became the seeds of galaxies and stars. By mapping these variations, scientists can read the universe's early conditions like archaeologists studying ancient bones. The patterns reveal the age, composition, and curvature of the cosmos. Each patch of that ancient light tells a story about what the universe would one day become. When you see an image of the CMB, you are looking directly into the first visible moment of time itself. Time itself was born when the universe cooled. In the earliest instance after the Big Bang, the universe was so dense and chaotic that the very concept of time may not have applied. Quantum effects blurred distinctions between before and after. Only as the universe expanded and cooled did space-time stabilize, allowing events to occur in sequence. The cooling of the cosmos was not just a thermal transition. It was the birth of ordered time. From that moment onward, the universe could remember. The laws of physics crystallized, and with them came the rhythm we now call the passage of time. Before that, quantum foam ruled, timeless chaos. At scales smaller than atoms, near the beginning of everything, space-time may have been a restless foam, quantum fluctuations, endlessly bubbling in and out of existence. In that realm, time as we know it breaks down. There is no clear direction, no stable sequence, only probabilities. Physicists call this the Planck era. The first 10 superscript 3 seconds, where the universe was too small and energetic for classical physics to describe. In that seething chaos, time was not yet a river. It was a storm of possibilities. Only after expansion smoothed the foam did the universe settle into something that could age. The flow of time slowed as space expanded. In the universe's youth, everything happened at unimaginable speed. Energy densities were enormous, interactions constant. As space expanded, that frenzy cooled. Atoms formed, galaxies condensed, and the tempo of cosmic events slowed. Time, in a sense, relaxed. The expansion stretched not only distances, but durations. Today, in a cold, sparse cosmos, processes unfold much more gently. A star can live for billions of years. What once was a torrent is now a tranquil drift. The slowing of time's rhythm is the universe's own form of aging, the calm that follows its fiery youth. Some regions may age faster or slower. Relativity reminds us that time does not flow at the same rate everywhere. Regions of stronger gravity, near galaxies, clusters, or black holes, experience slower time than the vast, empty voids between them. On the scale of billions of years, these differences accumulate. Some parts of the cosmos are slightly younger or older than others, depending on the gravitational fields they inhabit. Even cosmic time, that great unifying measure, is not perfectly even. The universe's clock ticks irregularly across its own face, stretched and compressed by its own geometry. Black holes trap time. Voids let it race ahead. Near a black hole, time slows dramatically. At the edge of the event horizon, it nearly stops relative to distant observers. Light struggles to escape, and processes seem frozen. In contrast, the vast cosmic voids, immense, low-density regions between galaxies, experience weaker gravity, where time runs slightly faster. The universe, therefore, doesn't age uniformly. It is a patchwork of slow and fast zones, stitched together by gravity's hand. If you could watch from outside, you'd see time itself rippling like a fabric in motion, slowed near matter. Racing through emptiness, cosmic time is uneven across the universe. Though the difference is small, it's real. The universe's geometry ensures that time is relative even on cosmic scales. In dense clusters of galaxies, clocks run slower. In the emptiness between them, they run quicker. The result is a subtle distortion of the cosmic timeline, a reminder that the universe, though vast, is not uniform. The great cosmic clock does not tick evenly everywhere, yet the music it plays is harmonious. From our limited view, it feels like a single rhythm, but in truth, the universe keeps time in chords, layers of tempo intertwined across infinity. Galaxies drift through different ages. Each galaxy moves through space-time along its own trajectory, carrying billions of stars in its gravitational grip. Some galaxies are already old, their stars dim and red. Others are still young, blue, and bright, full of new suns being born. Though all share the same cosmic age, their internal clocks, their rates of evolution, differ. A galaxy's history depends on its density, its collisions, its environment. The Milky Way, too, is aging, forming fewer stars than it once did. Across the universe, galaxies are like instruments playing at slightly different tempos in the same grand symphony of time. The universe's future is still unfolding. Even after nearly 14 billion years, the story is far from over. Stars continue to form, galaxies collide and merge, black holes grow, and space expands ever faster. Time, on a cosmic scale, stretches onward, pulling everything apart. The universe's timeline extends into unimaginable futures, trillions of years ahead, when stars fade, matter decays, and only darkness remains. Yet in this moment, we live in its bright middle act, an era of light, warmth, and life. The universe is still writing its story, one slow heartbeat at a time. If expansion accelerates, time will stretch endlessly. Observations show that the universe's expansion is speeding up, driven by mysterious dark energy. If this acceleration continues, space will expand forever, and cosmic time will stretch without bound. Galaxies will drift beyond visibility. Stars will die in solitude. To future observers, if any remain, time itself will seem to slow as distances grow. Infinite. Each moment will feel longer, quieter, more diffuse. The universe will not end with a crash, but with a fading, an infinite sigh into eternity. In that slow unfolding, time may dissolve back into the stillness from which it began. Cosmic time is the heartbeat of existence. From the first pulse of the Big Bang to the final whisper of entropy, cosmic time marks the rhythm of being. It beats not in seconds or years, but in epochs, in the births and deaths of stars, in the rise and fall of galaxies, in the long arcs of cosmic evolution. Every moment, from the smallest vibration to the grandest collision, is part of this great metronome. The universe lives, breathes, and ages through its clock. And as we watch it, measure it, and ponder it, we too become part of that rhythm. A brief, conscious flicker in the long, eternal heartbeat of the cosmos. Quantum physics treats time differently. In the strange language of quantum mechanics, time is not the same kind of variable as space. The equations that describe particles, like Schrödinger's equation, treat time as something external, a fixed backdrop against which everything unfolds. Space can fluctuate, twist, or superpose, but time, curiously, does not. It sits outside the dance, a silent metronome that never joins the rhythm. Yet, in the quantum world, nothing is truly separate. Time, too, must be part of the system. The more we look into the foundations of physics, the more we suspect that time, like space, may not be fundamental at all, only an emergent illusion born from the relationships between things. In quantum equations, time is fixed, not a variable. Most quantum equations describe how a system changes in time, but they never describe how time itself behaves. Time enters as a parameter, not a dynamic quantity. You can solve for how an electron's position evolves, but you can't solve for how time evolves, because the equation assumes time already exists. This is called the problem of time in physics, the uneasy realization that our most successful theories treat time as both essential and undefined. In quantum mechanics, time drives everything. In general relativity, time is flexible and curved. Uniting these two views is one of the deepest challenges in science. But particles behave as if time flows. Despite its abstract treatment in equations, the quantum world seems alive with motion. Particles oscillate, decay, and interact as if they exist within a flowing current of time. Quantum states evolve, probabilities shift, wave functions spread. Even when time isn't explicitly part of the math, behavior implies sequence. A photon emitted here is absorbed there. An atom's energy changes step by step. It's as though time sneaks into quantum mechanics through the back door, guiding the unfolding of events even when the theory claims not to need it. Somewhere between the equations and our observations, time emerges, uninvited but unavoidable. The quantum problem of time remains unsolved. For decades, physicists have tried to reconcile quantum mechanics with Einstein's relativity to build a theory of quantum gravity that explains both the very small and the very large. But time stands in the way. In relativity, time is part of the geometry of space-time, shaped by matter and motion. In quantum physics, it's a fixed parameter. When you try to combine the two, they clash. Some versions of quantum gravity predict that time simply disappears from the fundamental equations, that it is not a basic ingredient of the universe. If that's true, then time is not something the universe has. It's something we perceive. At small scales, time may not even exist. At the Planck scale, the unimaginably tiny realm of 10 superscript 3 meters, the distinction between before and after may dissolve entirely. In this domain, quantum fluctuations are so violent that space-time itself becomes fuzzy. The notion of a smooth timeline breaks down. Events can't be ordered in a definite sequence. This is the quantum foam, a seething ocean where space-time bubbles in and out of existence. Here, the universe is not a movie playing frame by frame, but a swarm of possible frames overlapping at once. Time, as we know it, may simply not apply. It's not that time stops, it's that it has not yet begun. Space and time could emerge from entanglement. A growing school of thought suggests that both space and time might emerge from quantum entanglement, the mysterious connection between particles that remain linked across distance. In this view, the geometry of space-time arises from patterns of entanglement among quantum bits of information. The more connected they are, the more space and time appear. If all entanglement were lost, space-time itself would vanish. This idea turns our intuition upside down. Reality may not be built from matter and energy, but from relationships, from the invisible network of connections that generates the illusion of location, sequence, and duration. Quantum events blur before and after. At the quantum level, cause and effect become slippery. A particle can take multiple paths at once, existing in a superposition of outcomes until measured. Before observation, there is no clear order, no definite first or second. When an event happens depends on how you ask the question. Experiments like the delayed choice quantum eraser show that a measurement made after an event can influence how we interpret what happened before. In this domain, the boundaries between past and future blur into something timeless, an interconnected web where sequence is secondary to relationship. Cause and effect can reverse. In quantum experiments, it sometimes appears as if the future can affect the past. When scientists change a detector after a particle has already entered the apparatus, the results still shift, as though the particle knew what was coming. This doesn't mean information truly travels backward, but it shows that the universe at its smallest scales doesn't obey our linear sense of time. Instead of a one-way chain of cause and effect, reality behaves more like a network of correlations, timeless and holistic. What we call cause and effect may just be two sides of the same simultaneous equation. Experiments show information can move backward. In 2012, physicists performed an experiment demonstrating quantum retrocausality, where choices made in the present seem to determine the behavior of particles in the past. When they changed the settings of a detector after photons had been emitted, the pattern of results changed accordingly. This doesn't mean that the past is rewritten. Rather, the quantum description of the system only becomes definite once the entire setup, past and future, is considered as a whole. In this sense, time in quantum mechanics is not a line, but a loop of correlation. The universe may decide outcomes holistically across all of spacetime. Yet on average, time's arrow holds. Despite these strange effects, the familiar arrow of time still dominates at larger scales. Entropy increases, heat flows from hot to cold, and memory points backward. Quantum strangeness averages out when enough particles interact. The microscopic reversibility of physics gives way to macroscopic irreversibility. The arrow of time reasserts itself not because the laws change, but because probability does. When trillions of quantum events combine, the chaos organizes into a clear direction forward. Even if the quantum world is timeless, the world we live in keeps its rhythm. The arrow may emerge from countless tiny arrows pointing nowhere. Quantum clocks tick in probabilities. In the quantum world, clocks don't tick in fixed intervals. They tick in probabilities. An excited atom might decay in 1 second, or in 2, or in 10, with no way to predict exactly when. All we can calculate is the likelihood. Even timekeeping itself becomes a matter of chance. Atomic clocks, the most precise we have, rely on the quantum oscillations of atoms, averaging over probabilities to achieve stability. Beneath their perfection lies uncertainty. Time, at its smallest scale, is not a steady beat but a shimmer, a dance of likelihoods, smooth only when seen from afar. The act of observation defines sequence. In quantum mechanics, observation is not passive, it shapes reality. The collapse of the wave function turns potential into actuality. Before measurement, events exist in a cloud of possibilities. After, they solidify into one outcome. Observation, then, defines not only what happens but when it happens. The sequence of events becomes meaningful only when observed. This raises a haunting possibility, that the flow of time itself depends on consciousness, that awareness is what knits the universes. Probabilities into a coherent story. Without observation, there is no narrative, only timeless potential. Time might emerge from consciousness itself. Some physicists and philosophers go further. Perhaps time does not just exist for consciousness, but because of it. Our awareness experiences change sequentially, translating timeless quantum reality into the familiar rhythm of before and after. In this view, the mind is a bridge between eternity and duration, a filter that turns the infinite present into a stream of moments. Without that filtering, everything might happen at once. Time, then, could be the mind's most profound act of creation, the transformation of pure being into experience, of infinity into story. In quantum cosmology, the universe is timeless. When scientists apply quantum principles to the entire cosmos, time often disappears from the equations altogether. The most famous example is the Wheeler-DeWitt equation, which describes a universe with no explicit time variable. The universe, in this model, simply is a static wave function containing all possible configurations. Change and sequence arise only for observers within it, not for the universe as a whole. This is sometimes called the frozen universe, not because nothing happens, but because everything already has. From outside, the cosmos is eternal and still. From within, it hums with the illusion of motion. Time may be an emergent property, not fundamental. In the same way that temperature emerges from the motion of molecules, time may emerge from the entanglement and correlation of quantum states. When enough systems interact, their combined relationships give rise to a sense of order, a direction of change. Time, then, is not built into the universe at the ground level. It's a large-scale phenomenon, like the waves on an ocean. Beneath the surface lies only timeless quantum foam. What we call the flow of time is a macroscopic illusion, the statistical smoothing of countless microscopic fluctuations that have no inherent direction. Some say the universe is a wave of being. In this poetic but precise metaphor, the universe is not a sequence of events, but a single, standing wave, a vibration existing all at once. Every possible configuration of matter and energy coexists within that wave, overlapping and interfering. We perceive motion because our consciousness samples the wave in slices, like a melody heard one note at a time. But in truth, all notes ring together. The universe doesn't evolve, it resonates. Existence itself is a vibration across timelessness, and time is the resonance we hear when we listen closely. Past and future are interference patterns of now. In quantum theory, the present moment is not isolated. It's shaped by waves arriving from both the past and the future. When they meet, they interfere, creating the patterns we call reality. The now we experience is the product of these overlapping influences, a point of constructive interference between what has been and what will be. The past sends its echoes forward. The future sends its possibilities backward. Together, they form the shimmering present, where all potential collapses into experience. Time, in this view, is not a line, but a harmony of influences converging on the eternal now. In this view, eternity is not endless, it is depth. Eternity is often imagined as infinite duration, an endless stretch of time. But in the quantum sense, eternity has no length at all. It is not more time. It is outside time. It is the totality of all possible moments coexisting in a single reality. To step into eternity would not be to live forever, but to see all things at once, every birth, every star, every heartbeat layered together in a single infinite depth. Time is the unfolding of that depth into sequence, a way for finite minds to explore the infinite through experience. Each moment is a standing wave in reality. Every instant of existence, from the flicker of an electron to the turning of galaxies, can be thought of as a standing wave in the cosmic field. Each wave resonates briefly, interacting with others, before fading into new configurations. These waves do not move through time. They are time, temporarily stabilized patterns in the quantum ocean. Reality, then, is not a flow of things through time, but a tapestry of moments, each one a frozen vibration, forming and dissolving in the eternal field. What we call the present is the crest of that wave, always here, always changing. Time is the quantum melody of existence. If the universe is a vast symphony of probabilities, then time is its music, the rhythm that turns vibration into experience. Each particle, each field, contributes a note to this invisible composition. The harmonies of motion, decay, and interaction create the melody of being. From the quantum scale to the cosmic, time is the resonance of reality itself, not an external beat, but the music emerging from the interplay of everything that exists. We are not listeners to that music, we are part of it. Every heartbeat, every atom, every moment adds its tone to the eternal song of the universe. Time began, and it may end. Every story that begins must also conclude. The universe, vast and ancient, is no exception. Time itself, that silent current carrying galaxies, stars, and minds, may one day come to rest. It began with the Big Bang, when energy and space burst forth from a single point of potential. And just as it had a birth, it may have an ending. Time is not eternal motion. It is a process, a cosmic unfolding that depends on change. When change ceases, so too may time. The story that began in light may close in perfect stillness. When entropy reaches its maximum, motion stops. Entropy, the measure of disorder, drives the arrow of time. It increases with every event, every transformation. But what happens when there is no more order left to lose? When entropy reaches its peak, energy will be evenly distributed. There will be no gradients, no flows, no reactions. Without contrast, nothing moves. Without movement, time loses its meaning. The universe will fall silent, not because it has ended, but because nothing within it can change. The cosmic clock will no longer tick, not broken, but fulfilled. Stars will fade into black dwarfs. Far in the future, tens of trillions of years from now, the stars will exhaust their nuclear fuel. The bright points that fill our skies will gradually wink out, one by one. Red dwarfs will cool and darken into black dwarfs, cold remnants of what once shone. The universe will become a quiet field of cinders, matter still existing, but without light. Each black dwarf will be a monument to a star's long life, its atoms frozen, its fusion heart forever stilled. Night will deepen across the cosmos, until even the galaxies grow invisible. Black holes will evaporate in Hawking radiation. Even the mightiest objects will not last forever. According to Stephen Hawking's prediction, black holes slowly radiate energy due to quantum effects near their event horizons. Over unimaginable timescales, they will lose mass and fade away. The largest black holes may take 10 years to vanish, but vanish they will. The cosmos will watch, if it still can, as the last black hole dissolves into a faint whisper of energy. The ultimate engines of gravity will become nothing more than gentle ripples in space-time, the final echoes of structure in a dissolving universe. Galaxies will drift beyond each other's sight. As the universe's expansion continues to accelerate, galaxies will recede faster and faster. One by one, they will pass beyond the cosmic horizon, the limit of what can be seen or reached. In a few 100 billion years, only the nearest remnants will remain visible. To future observers, the night sky will appear empty. The universe will seem small, even though it has grown vast beyond comprehension. Light from distant galaxies will never reach us. The cosmos will become isolated islands of matter adrift in a sea of expanding darkness, until even those islands dissolve. The universe will cool toward absolute zero, with the stars gone and the energy of radiation stretched thin. The universe will grow cold. Every particle will drift farther apart, their motions slowing. The temperature will approach absolute zero, where kinetic energy ceases. Molecules will freeze, atoms will barely vibrate. The once fiery cosmos will settle into near-perfect stillness. The great furnace that birthed galaxies will become a dim, frozen haze. The expansion will continue, but there will be no warmth left to measure it by. Space will not end. It will simply become too cold to care. Quantum fluctuations will quiet, even in apparent emptiness. Quantum physics ensures that tiny fluctuations of energy flicker in and out of existence. But as the universe expands and cools, even those fluctuations will fade. The vacuum itself will grow still. The dance of particles and antiparticles, the quantum foam at the foundation of reality, will calm into near silence. When those last ripples fade, there will be nothing left that can create difference or motion. The universe will become not empty, but perfectly balanced, a mirror with no reflection, a sea with no waves. Without change, there will be no time. Time is not a thing, but a relationship, a measure of change between events. If nothing changes, there is no before or after, no difference to mark. Duration. When entropy reaches its limit and motion ceases, time will have no anchor. It will not stop like a broken clock. It will simply cease to exist as a concept. Without transformation, time has no meaning. The universe will remain, but the story will be over. All that will persist is existence itself, timeless, formless, complete. This is the heat death of the universe. Physicists call this ultimate state heat death, not an explosion, but an extinction of difference. All temperatures, all energies, all motions will equalize. It's not destruction, but equilibrium. The perfect balance where nothing can happen. In this vast stillness, no new stars will form, no atoms will collide, no energy will flow. The universe will reach its thermodynamic end. Maximum entropy, zero change. It will not vanish. It will simply finish. What began as a blaze of creation will end in the quiet of infinite calm. But some theories say time could restart. Yet even this silence may not be forever. Some cosmologists propose that when the universe reaches its most uniform state, quantum fluctuations could once again trigger new expansion, a new big bang from the ashes of the old. In this view, time is cyclic. The universe breathes in and out, eternally reborn. Each collapse, each silence, Each end contains the seed of another beginning. The end of time in one cosmos might be the dawn of time in another. Creation and dissolution may be two sides of one eternal pulse. A new Big Bang could emerge from the old. In the quantum void of heat death, the vacuum may not remain empty. Random fluctuations, tiny bursts of energy, could give rise to new spacetime bubbles. Each bubble could inflate into a new universe, complete with its own time, space, and laws of physics. To us, the old cosmos would seem finished. To a new universe, it would be the womb of creation. Time would be born again, flowing through a new reality. The multiverse, if it exists, may be an infinite chain of such rebirths, universes emerging like sparks from an eternal fire. Time could be cyclic, endless rebirth. Some ancient philosophies already imagined what physics is only now exploring. That time moves in cycles, not lines. Creation and destruction are part of the same rhythm. The cyclic universe model suggests that after eons of expansion, gravity or dark energy reverses the process, pulling everything back into a collapse, a big crunch that ends one age and begins another. Then, from that compression, another explosion. A new timeline begins. Each cycle is a universe remembering how to be born. The arrow of time bends back on itself, completing the circle. Other models suggest big freeze, eternal stillness. The simpler and colder scenario is the big freeze, the idea that the universe expands forever, cooling endlessly. There is no rebirth, no reversal, no second act. Space stretches beyond coherence. Until every atom is isolated, every photon redshifted into invisibility. Nothing ever collapses, everything drifts. It's an eternal fading, where time stretches toward infinity, but nothing new happens. The universe doesn't end, it empties. This, too, is a kind of peace, a cosmic sleep without dreaming. Some propose Big Rip, where time itself tears. If dark energy grows stronger over time, the expansion may accelerate so violently that it rips the universe apart. Galaxies, stars, planets, even atoms, would be torn from within. This is the Big Rip scenario. In its final moments, time itself would stretch infinitely, then break. The sequence of cause and effect would dissolve. Clocks would stop, not because they ran out of energy, but because space-time itself ceased to exist. The universe would not cool into stillness, it would shatter into non-existence. And perhaps, beyond that rupture, something entirely new might begin. The future may be a quantum sea of silence. Whether by freeze or rip, the far future may return to quantum stillness, the same condition that existed before the Big Bang. Particles will fade, radiation will vanish, and only the trembling of the quantum field will remain. In that sea of silence, the universe will not end, but dissolve into pure potential. Everything that was, every atom, every memory, every heartbeat, will exist only as possibility within that boundless field. Time will no longer flow, because there will be nothing left to measure. Yet in that silence, all beginnings remain possible. Perhaps time will dissolve back into timelessness. If time had a beginning, it may also have a destination, a return to where it came from. In the deepest stillness of the future, time may not end but merge, blending back into the timeless source from which it first emerged. The river returns to the ocean. The motion that once carried galaxies now rests as still awareness beyond before and after. In that sense, time is not destroyed but completed, having carried every event, every life, every possibility to its destination, the calm of eternity. Or consciousness will remain beyond clocks and stars. Perhaps, even when all matter fades, awareness will persist, not human, not local, but cosmic. Consciousness might not depend on form or energy, but be the ground from which they arise. If so, the end of time would not be the end of being, but its transformation. When the lights go out, what remains may be the pure presence that witnessed them. In the silence beyond physics, awareness could remain, vast, timeless, and unbound, observing itself in the dark. In that void, time's meaning might transform. At the end of time, the question, what comes next, may no longer make sense. The very grammar of change will vanish. Duration will dissolve into presence. The concepts of past and future will collapse into a single, infinite stillness, not nothingness, but wholeness. The end of time may not be destruction, but understanding. The realization that time was never separate from eternity, only a way for eternity to know itself in motion. When time ends, awareness may simply awaken from the dream of sequence. The end of time may be the beginning of awareness. When all clocks have stopped and every process has ended, what remains might be pure consciousness, the eternal witness beneath all change. Perhaps time's final act is to reveal that it was never apart from awareness, only a reflection of it. The universe may awaken not into chaos, but into clarity, a return to the quiet knowing from which it once arose. The end of time is not a fall into nothing, but a return to everything. It is the still point where existence recognizes itself. Eternity is not endless time. It is no time at all. We imagine eternity as infinite duration, but that is a misunderstanding. Eternity is not the endless continuation of moments. It is the absence of moments entirely. It is pure being, unmeasured, undivided, beyond past and future. The end of time is not the loss of existence, but its purification. When the last light fades, and the final second dissolves, what remains is eternity itself, silent, infinite, complete. The universe will not die into emptiness, but awaken into stillness. Time will have finished its work, and what is left will be the eternal now. Time gives meaning to existence. Without time, there would be no story, no birth, no becoming, no journey to tell. Time transforms stillness into experience, turns existence into unfolding. It is not merely a dimension, but the canvas upon which everything happens. Through time, the universe learns to know itself. Every instant, from the flicker of a cork to the blooming of a star, carries meaning because it does not last. What gives life depth is not permanence, but change. Time is the breath of being, the rhythm that turns chaos into creation, silence into song. Without it, nothing could grow or fade. Growth requires sequence. Decay requires difference. Even awareness depends on change to know itself. Without time, there would be no evolution, no aging, no transformation. A flower would not bloom, a star would not shine, love would not unfold. Time allows all things to move from potential to reality, from simplicity to complexity. It is the invisible current that carries the universe from what was to what could be. Without it, there would be existence, but not life. Yet within it, all things pass. The same current that gives us life also carries us away. Every joy, every thought, every light will one day fade. Time is both gift and dissolution, the hand that creates and erases in one motion. To live is to move through impermanence. But impermanence is not cruelty. It is the reason anything can exist at all. The universe must change to remain alive. Within that passing lies beauty, a fleeting glow that becomes more precious because it cannot last. To live is to flow with time. We are rivers of consciousness, carried by time's current. To resist it is to suffer. To flow with it is to awaken. Each moment offers itself like water through open hands, impossible to hold, yet endlessly renewed. Life is not about stopping time, but learning to dance within its stream. Every decision, Every emotion, every step is a ripple across the infinite, a signature of movement within eternity's calm. To love is to defy it. Even briefly, love is humanity's rebellion against impermanence. When we love, we create something that feels timeless, a connection that outlasts moments, that ignores the ticking clock. In a universe ruled by entropy, love is a local reversal, a small pocket of order and warmth. It binds us through memory, through care, through meaning that endures beyond decay. Every act of love slows time's erosion, not in physics, but in the heart. Memory is time folded within the mind. Each memory is a wrinkle in consciousness, a fragment of time preserved. When we remember, we step outside the present, traveling backward through inner space. The past is never gone. It is stored as patterns of neurons, electric echoes of what once was. In remembering, we keep time alive. Within ourselves, our minds are not clocks, but archives, small universes holding entire galaxies of yesterday. Hope is time opening toward the future. Hope is the mind's way of reaching forward, a hand extended into what does not yet exist. It is faith in continuation, in possibility. Hope transforms uncertainty into direction, gives shape to the future before it arrives. It is time's mirror. Image of memory. One looks back with gratitude, the other forward with courage. Together, they create meaning in the middle, where we stand, breathing between what has been and what may be. Regret is time echoing backward. When we regret, we replay old moments, wishing to rewrite them. But time does not rewind. It teaches instead. Regret is the shadow of awareness, the reminder that choices matter. It connects us to our past selves and invites forgiveness. The echo cannot change the sound, but it can deepen our understanding of it. Regret, too, is part of time's compassion, a way for us to evolve through reflection. Dreams are bridges between what was and what might be. In sleep, the mind travels freely across time's boundaries. Memories mix with imagination, and the future whispers through symbols. Dreams are how consciousness explores time without constraint, rewriting the past, rehearsing the future, and sometimes touching something timeless. In dreams, time bends into meaning. They remind us that even when we rest, we are still participating in the universe's great experiment of becoming. We are creatures made of time, yet longing for eternity. Every cell in our bodies follows rhythms, heartbeats, breaths, cycles of sleep and growth. We are built from time, shaped by its flow. Yet deep within, we yearn for something beyond it. Stillness, peace, permanence. This longing is not denial, it is recognition. We sense eternity because we are made from it. The timeless whispers through us, even as we move through hours and years. To exist is to live between those two truths, the changing and the changeless. Each heartbeat measures the universe in miniature. Your pulse is a cosmic clock, a rhythm echoing the cycles of stars and galaxies. Every heartbeat is both biological and universal, a microcosm of expansion and contraction. The same forces that drive cosmic inflation drive the flow of blood. In that simple rhythm, you mirror the cosmos itself. The universe breathes through you, fast or slow, but always in motion. You are not separate from time's fabric. You are one of its living threads. Every breath is a dialogue with space-time. When you inhale, you draw in atoms forged in ancient stars. When you exhale, you return them to the world. This exchange, so simple, so constant, is a conversation with time. The air that fills your lungs once passed through oceans, trees, and distant creatures. Each breath connects you to every moment that came before and every one yet to come. To breathe is to participate in the universe's eternal rhythm, the in and out of existence itself. Stillness, too, is part of time's music. We often think of time as motion, but stillness has its own tempo. The pause between heartbeats, the silence between notes, these are also measures of time. Stillness is not the absence of flow. It is the resting point that gives flow meaning. Even the universe, expanding and cooling, moves toward a deeper stillness, not death, but harmony. In stillness, time does not end, it listens. The universe expands, and so do we. As space stretches, so does awareness. The same creative impulse that drives galaxies outward drives thought, emotion, and imagination. We, too, are unfolding, learning, changing, becoming more intricate. The expansion of the universe is mirrored in the expansion of consciousness. The cosmos grows in size. We grow in understanding. Time is the field upon which both journeys play, outward into infinity, inward into depth. Time may not end. It may only change form. Perhaps time never truly disappears. It only transforms, cycling through states we cannot yet perceive. What we call the end may be a shift to another mode of existence, where sequence becomes presence and motion becomes awareness. Time might not die. It might awaken. In that awakening, the universe could discover new ways to express itself, new symmetries beyond our comprehension. The story continues, only the language changes. Every moment is eternity, seen from within. If you look closely, every second contains infinity. Within each breath, each thought, lies the entire structure of being, birth, growth, decay, and renewal, all happening at once. Eternity is not far away. It's inside every moment, waiting to be noticed. When we become fully present, time dissolves, and eternity reveals itself, not as endlessness, but as fullness. The infinite hides in the instant. The present is where all of time converges. Past and future meet only here, in the now. The present is the intersection of all timelines, the still point through which every possibility flows. We can't touch the past or the future directly. We experience them both through the lens of this eternal moment. The present is not a fleeting slice between what was and what will be. It is the foundation of both. Every breath, every heartbeat, every thought arises here, in the meeting point of all that ever was and all that will ever be. To rest is to return to the source, timeless awareness. When you rest, you are not escaping time. You are returning to the stillness beneath it. Sleep, meditation, and peace are windows into timeless awareness, the silent background from which all motion emerges. To rest deeply is to align with the same calm that underlies galaxies. It is to touch the part of yourself that was never born and will never die, the still witness beneath the ticking clock. Time moves, but awareness remains. The stars are ancient clocks, whispering eternity. Look up, and you are looking into time itself. Every star is both a measure and a message, a luminous record of cosmic history. Their light has traveled for millennia to reach your eyes, carrying the memory of creation. They remind us that we are made of the same material, bound by the same laws, illuminated by the same fire. The stars do not rush, they simply burn. Their patience is a lesson in eternity, shining quietly across the ocean of time. And as you drift to sleep, you join that rhythm, the quiet pulse of the cosmos. Now let everything slow. Let your breath match the rhythm of the stars. The universe moves gently, and you move with it. There is no hurry, no destination, only unfolding. As you rest, you return to the timeless sea that has always held you. The pulse of your heart, the silence of the night, the hum of distant galaxies, all are one rhythm, one presence, one peace. Time softens, space opens, and you drift, weightless, into the calm beyond beginnings and endings. The journey is complete. Time continues, and so do you. Thank you for listening, sleepy friend. Tonight, We traveled across the ages, from the birth of time to its quiet end. We saw how every heartbeat, every thought, every star is part of one great rhythm, the pulse of the universe itself. Time gave us beginnings, endings, and everything in between. But beyond all of it, there is something still, something timeless, waiting in the silence. When you rest, you touch that stillness. You return, softly, to the source that made the stars and you. So let your mind drift now. Let the past and the future fade away. There is only this breath, this moment, this calm. You are safe. You are home in the universe, and the universe is home in you. If this journey helped you relax or dream a little deeper tonight, I'd love for you to stay. Subscribe, and join me again among the stars. Until next time, sleep well, traveler, and may you always drift gently in the rhythm of time.